Hello, good evening to everyone. So today we are going to discuss one of the questions from day 1 2026, which is from the organic chemistry part. And in this question, what has been asked is we have two molecules. The first one is this molecule, the other one is this. These two molecules have been reacted with BH3H plus and lithium borohydride H plus. These two reagents are selectively reduced from the carboxylic acid ester, and how they behave, we should know that for solving these type of questions. So to start this question, so if you see the question is like it has been given for solving this type of question, we should know one thing: that BS3 with H plus, BS3 with H plus, what to do? It reduces carboxylic acid in the presence of ester. We can say that not reduces ester. And lithium borohydride, LiBH2, it is also given there is that this reagent reduces ester in the presence of acid. We can say that not reduces acid. So they both behave differently. So what is given in the question is we have a four-membered ring like this. Okay. In this four-membered ring, we have a methyl group. If you move, functional groups are there. One is the COAT, the other one is the COOH. So the second molecule is like this. And we are going to react these molecules with BH3. The step, the second step is expressed. Similarly, here also BH3. The first step and second step is expressed. And similarly, in the second part of the reaction, first step is lithium borohydride. The second one is the expressed. Here also LiBH4, and the second one is expressed. So what happens here is when it reacts with this, when it we know that the boron with the H plus, reacts with acid, give reduces acid to alcohol, and also in the presence of H plus, this ester will be hydrolyzed and it will be hydrolyzed to acid. Similarly, this CH3 will remain the same. Similarly, in the other that part also, this is CH3, so CH3, and this will be the COOH, and this will be reduces to alcohol. Similarly, when we react it, then CH3 will remain same, and become this will become alcohol. This will remain same. Similarly, here also this will impact. This will remain impact, and here ester will be reduced to acid, and the acid will ester will become alcohol, and the acid will remain same. So what have been given is, if you see here, this is P, this is P, this is Q, Q, and this is R, and this is S. So what we have to tell, the relation between the P and Q. If you see P and Q, then you can see that the in P and C, Q, this center is parallel center. This center is parallel center, which has the same stereochemistry. We can say that it has the same configuration. And the other parallel center, this center is also parallel center. And this parallel center has opposite stereochemistry or the configuration. As we can see that above in the P molecule above is OH, and here in the Q molecule below is OH. So there is an opposite configuration. So we can say that whenever this happens, the one stereo center is same, the other stereo center's configuration is opposite. And we say that those two molecules are diastereomers. So we can say that P and Q are diastereomers. Why? Because these two centers have the same configuration, but the other center has the opposite configuration. Whenever this happens, when any of the centers, any of the serial center have the opposite configuration, remaining all are the same configuration. You say that those two molecules are diastereomers. Okay. Similarly, when we compare RNS, so in RNS we can say that we can see these two centers. From these two centers, there is a restricted rotations of four membered ring. And if you see that here CH3 and OH are on the same side, and here CH3 and OH are on the opposite side. We can say that they are E and Z type. Okay, so we can say that these two molecules are the GI of the metal ion, and all GIs are diastereomers. So that's why R and S are also diastereomers. From this, we can say that from these options, C option is correct because P and Q are diastereomers and also R and S are diastereomers. Hope you understand the solution. Thank you for listening.